1, 2, 3, 4, 5, 6, 7, 8, and 9. 1, 2, 3. Look, here you can also say this is also in nodes. Okay, because two elements are joined over there. So you can say this is also in node. So 1, 2, 3, that is 4, that is 5, that
Okay.
is 6, that
So
is
very good morning. We
7,
will wait for 5 to 10 minutes.
that is
Then
8,
we will start our
that is
session.
9, that is 10. Okay, so number of nodes is 10. Now, second question, third question is which one was a junction? Junction. Junction, as per the definition, two or more elements are joined. So junctions are only three. Look, this is your junction. This is your junction. Okay. This is your junction, and another junction is H. So at one, two, and three. Look, nodes are 10, but junction are three. Only two or more circuit elements are joined over here. That is called a junction. So junction is three. And what else the branches? Branches. Okay. Thank you. Yes. Now it is the branches. Which one are the branches? Uh, this this is the branch. This is the branch. This is also called a branch. This is also called a branch. This is a branch. This is a branch. So this is also a branch. This is also a branch. This is also a branch. Or this is also a branch. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and that is 12. This is the circuit elements, 12. But you have to set a branch. Look, this is totally, it is considered a branch. Look, this is a branch, this is a branch, this is a branch, this is,
Yeah. A very good morning. We will wait for 5 minutes. Then we will start our session.
so 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, branch is 12. Now, for the base, base, which one is the base? Base is this one is the base one, this one is the base two, and this is the base three. So base is three. And if you told me what which one are the loop, say loop is so many that I will show loop. This is a loop in one. This is a loop in two. This is also a loop that is in two. This is a loop that is in four. This is a loop that is in five. And this one also a loop outer loop is six. So number of loop is six. So guys, I think you can get the total idea of this of the elements of circuit. Circuits in मेष एंड लूप में क्या डिफरेंस है? देखो मेष होता है एकदम एलिमेंटेड मीन्स ओनली इट नॉट बी डिवाइडेबल से दिस इज here is a loop okay because any closed path is called a loop so this is a loop 3 but this is a loop this is a small loop this is a loop 1 this is a
Okay,
loop
so
2
we will
okay
wait
any
for
closed path but which one is the
another
loop
few
a
minutes
is the
because
only
okay.
single element it will not be
Acha,
dividable
Deepak
by
Banwal is there or not?
this loop is dividable by 1 and 2 but loop 1
Good morning, sir.
is dividable
So you
no
were asking
it's a
one question.
single loop it's
Hello?
Hello. Is my voice is audible to you?
what is single जो बोलो ना atom होता है
Is my voice is audible to you or not?
ये होता
Yes,
है
sir.
element
Okay.
so
So
this loop
you are
Yes,
asking
sir.
one question in the WhatsApp.
but it is not a
Okay,
maze only this
right.
is maze 1 this is maze 2
Today's morning.
Yes,
you
sir.
can't divide it
Okay.
this maze loop
So the
m1
thing is that yes,
maze
this is your
but you
syllabus.
can't
Yes.
Okay.
divide it
So up
but
to
within
this,
this loop
whatever
it is divided
the
by
syllabus up to which module I have been
did
taught.
you understand
Okay, up to this, that will be your first
hello
internal examination. Okay.
okay so this
Suppose
is
if
the
I
maze
complete the
1
module
this
1
is
and
the
the
maze
module 2,
2
then that will
this is
be
the maze
module
3
and then the module 2, that
but
is
you
your
can't say this is
syllabus.
totally a maze 4
Okay.
no it is not a maze because it is divided
Is
by
that clear?
3 more mazes
Because
maze
till
is the
now
Yes, sir.
the
Clear.
yet now
this is the
date is
one
not been
divide
decided.
and cut out
Okay, so
तब maze हो गया loop क्या है
that is
any
why
close path
I will
any close path
proceed
then
our
this
module 2
this is the
also.
circuit
Okay, because two
then
more
this is
days
not a loop not a maze because
Okay.
it
will
is not closed
I will
okay so I
adjust the
think you
module
get
1.
this idea
Okay, and after that I will start
and
the module 2.
there
Okay,
is
so
a
two classes
second
more
say
I required for the module 1. Okay.
Okay, sir.
Okay, fine.
Thank you, sir.
Okay. Anche?
there is a sign convention okay
Okay, we will wait for 1 to 2 minutes, then we will start our session. Okay.
minus 2 plus if it is right
If my connection is lost during
within the
my
bracket
classes,
within the
okay, you
bracket
keep patience because
if it
sometime
is
it may
minus
happen
2
the
plus
internet connectivity
okay
will
but
lost
in the circuit
due to load shedding.
if it is
Okay, so you
it is
will wait
connected
for 2 3
in the
minutes. I will
circuit
again rejoin.
it is
Okay,
plus to
and
minus
if
okay
it will be
so in
any
this
issues
case
in the from the
in this
network
case
side, I will
this is
communicate in the
right
WhatsApp
voltage
whether the class will
because
be
from negative
continue
to
or not.
positive but outside of this circuit there
Okay,
is a
so we will wait
positive
for
to
1 to 2 minutes.
negative
Someone will
falling
like
voltage
more join.
so
Okay,
rise
then we will start our session.
in voltage is treated as flux and fall in fall in voltage is treated as negative sign. So if you do this sign, if you put this is positive, then you have to consider this part as a negative. Okay. So we have to write down the equation for the wave and the loop analysis. So guys, up to this, I need this. The next class will be started. Okay, or 2 or 3 minutes. Just write down this. We rise in 14 plus and assume to positive. স্যার আপনি 10-40 থেকে তো করতেই
আগের দিন ক্লাসটা হয়ে গেল না, এই কারণে একটু আগে থেকে শুরু করেছি।
পজিটিভ y a all potential potential can be con- considered. What is the potential difference? Just like a tank. I am saying this for the ECG primary students. Look, if there is a tank is there, if the if the height is different, then only water will flow. Likewise, if there is a potential, in this is say this is 220 volt and this is the 0 volt or any voltage is lower than this, if you connect this, then only current will flow, high current will flow. But if there is a 220 volt and if it is also a 220 volt, then no current will flow. So you have to with some potential difference. Maybe it is negative, maybe it is zero, maybe it is any lower than. Okay, they only current will flow. This is the potential difference concept. So if I draw this circuit, if I draw this for you convenience, this is your battery, this is your positive.
ঠিক আছে 40 মিনিট হয়েছে।
এখানে 40 মিনিট অফ করে দিল তো এবার মাঝখানে 2 মিনিট আবার স্টুডেন্ট বলতে স্যার আপনি রেকর্ডিং অন করে দিন
আচ্ছা
আমি সব বাকি স্যার 33 মিনিট ক্লাস হচ্ছে স্যার
আস্তে রেকর্ডিং আছে। Okay, so is my screen is visible to everyone?
Yes, sir.
Okay, okay, fine. So in the yesterday's lecture, we will discuss about the how could I find the vector magnetic field in the stator when the at a time omega t that is equals to 0. Okay, so we will finding out today what will be at the time of omega t is equal to 90 degree, what will be the vector magnetic field, right? So for that cases, we have to draw the vector representation. Okay, so how could I did this? Okay, so this is my vector representation for the omega t equals to 0. Okay, so this side we are considering. So yes, I'm putting this color. 1 second. Okay, so this one and this one is my vector. Okay, so this is okay, so okay, some problem will be there. Wait. প্রবলেমটা কেন হচ্ছে? Okay, so these are the two vectors we are see. This will be my CC. Okay, so B of CC vectors. Okay, and this one is for my B of BB for the BB coil. Okay, so when the omega t equals to 0, কি problem হচ্ছে? 1 second, I have a problem issue is in my Okay, I have go to the new pages so that. Okay. Now, so today we will discuss about the vector magnetic field. Okay, so the vector প্রবলেম আসছে কেন বলো তো? One second, I will stop my screen. I will again share my screen so that you will able to see. Okay, now it is correct. Now we will share my screen. Now my screen is visible to you.
Yes, sir.
Okay, fine. So some of them will still coming. Okay, so the vector magnetic field, okay, in a stator when the time at the time omega t is equals to 90 degree, right? I already discussed what will be the magnitude and the vector. Okay, so at a omega t equals to 0 degree, and what will be the values of b net. Okay, so that thing, for the values of b net, that we are finding out 1.5 vm at an angle minus 90 degree, right? So now what will be the vector magnetic field for that? Okay, so we will again redraw. Okay. Yes. Okay. So this is my a dash, this is a, this is my c dash, this is c, this is b dash, and this is my b, right? So if I draw the vector representation for that, you have to draw a line of this, another line we are considering. Okay, okay. So this is my This is my B of, sorry, this is my BCC dash, BCC dash. This vector that will consist B of BB dash, and this will be the my total B net. Okay. In this axis, we are considering the BAA dash, right? As because we are considering BAA dash, that is equals to 0, right? So when omega t is equals to 90 degree, okay, so for that cases, what will be my representation? What will be my resulting net magnetic field? So for that cases, we have a current, okay. So each and every coils, the current will flow. So suppose uh, in a coil A dash, the current that will flow, that is I of A dash. Okay, at the coil B dash, the current that will flow, that will be I of B dash, and the coil C dash, the current that will flow, it should be I of C dash, right? So what will be the values of this particular current? Okay, so if I will consider the values of the particular current, okay, so I of A dash, that is equals to, mm, in a same loop, okay, so I of a dash, it will be lies with the 90 degree, okay. So the magnetizing current, which will be considered as a Im, okay, sine of 90 degree, okay, that will be the ampere unit. So what will be the current that will flow through I of B dash coil? That will be my Im sine of BB dash, okay. uh, this one, so it should be considered as minus 30 degree, and I of C dash, that will be the total magnetizing current into sine of इस rotations में अगर होगा in this particular rotations, so it will be considered as minus of 150 degree, okay. So this will be the flow of current, okay, in the coil, right? Okay, and the magnetic fields are, these are the current that will flow, okay. And what will be the magnetic field? What will be the magnetic field? B of A dash, we are considering omega t is equals to 90 degree, right? Okay, so B of A dash, that will be my total magnetizing field at an angle 0 degree. You already know these things. B of B dash, that is equals to, we are considering minus 0.5 bm at an angle 120 degree, and for the BCC dash, that is my minus 0.5 bm at an angle 240 degree, okay. So that is my actually the magnetic field when the omega t equals to 90 degree rotations, okay. So what will be the resulting net magnetic field? Okay, so what will be the resulting net magnetic field? So we have to add those, all those things. So B net, that is equals to, I think some of one is coming, okay. So B net, that will be my B of A dash plus B of B dash plus B of C dash, okay. So we put the values Bm at an angle 0 degree plus minus 0.5 means it's a minus half, okay, sorry, minus half bm at an angle 120 degree plus minus half of this one bm at an angle 240 degree, okay. So So there must have a cos function and the sine function, as we will told in the previous lecture. Okay, so we will again go to the new pages. If I will did this, so what will be my v net, that is bm, that is at an angle 0 plus minus half of bm at an angle 120 plus minus half of bm at an angle 240 degree. Okay, so if I will again redefine the equation, it will come according to the unit vector. Okay, so bm, this will be signify my x mod plus, sorry, plus minus minus, plus minus minus, we are now putting this one. Okay, this particular functions having a two functions, one is a cos functions, another one is a sine functions. Okay, if we are considering the unit vector x and as well as the unit vector y, because the unit vector x we are considering that the unit vector x is in the direction of x, okay, which will be the right of the direction, and the y direction we are considering the upward directions. Okay, so the vector unit vector x bar is a unit vector in a horizontal directions. Okay, and the vector y dash are in a unit vector for the vertical directions, right? So for that cases we are considering the cos function and the sine function of this particular section, right? So it should be minus half of cos of 120 degree x mod plus sine of 120 degree y mod. Okay, minus, now in this section, okay, minus half of cos of 240 degree plus sine of 240 degree y mod. Okay, so connection is lost. So sorry for the interruption. So there must have a connection problem due to power failure. Okay. So we will start within 1 minute. Wait for Okay, so I will okay, so I will share my screen so that you will able to see again. 1 second, I have a call. Hello. हाँ. हाँ. আমি তো স্যার এখন একটা ক্লাস নিচ্ছি, ক্লাস নিয়ে তারপরে হ্যাঁ 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 ঠিক আছে ঠিক আছে করে দেবো। ঠিক আছে, আমি আমি করে দেবো ওটা। ঠিক আছে। ঠিক। Okay, so is my screen is visible now?
Yes, sir.
Okay, fine. So here up to this we are there. So 100 sine of 240 degree. Why not? Then we have to put the values of cos 120, sine 120, cos 240, and the sine 240 degree. So what will be my this equation? That will come Bm, okay, x mod minus of half of इसको अगर करेंगे half of 240, that will be considered as, so here we have a mistake, it will consider as x, right? So this will come x mod minus root 3 by 2 y mod minus half of x mod minus of root 3 by 2, this one y mod, right? So again, if I will simplify these things, if I will simplify this and this, then it will come minus of x, it will be cancelled out. Okay, so it will come root 3 by 2 bm, and this one root 3 y, this function and this function and this. Okay, so it will come minus of root 3 y mod. Okay, so from there if I will calculating, it will come minus 3 root 3 minus 3 divided by 2, so it will come 3 by 2. Okay, bm into y mod. Okay, so again if I will redefine these things, it will come 1.5 bm at an angle, कितना होगा बोलो, कितना होगा
Five.
at an angle कितना, these are
90 degree.
these are the magnitude, Okay.
So 90 degree.
Yes, this is minus of 90
90
degree.
degree.
Okay, minus of 90 degree. Okay, so what is my actually the observation is when the omega t equals to 0. So for that cases we are having a b net that is equals to 1.5 bm at an angle minus 90 degree. Okay, so when the omega t equals to 90 degree, so here also my values of b net that is equals to 1.5 bm at an angle 90 degree. So what is actually the observation क्या है? That means the resulting, although the direction of the magnetic field is changes, okay, although the direction of the magnetic field has been changes, the magnitude that has to be constant. It may happen due to some reason. This particular angle may differ. Okay, here that is not differed. Okay, but it may happen due to some conditions. It may have differ. Okay, it may happen that the value that will come 1.5 bm at an angle 0 degree. Okay, when the my values of omega t that is equals to 90 degree due to some vector representation. Okay, but the magnitude whatever the directions is the magnitude should have unchanged. Okay, so magnitude has to be constant. Okay, so the magnetic field is maintaining. So what the thing is that the magnetic field, that means bm, that will be maintaining the constant magnitude while it will rotating in a counterclockwise directions. Okay, so if the rotation is in a counterclockwise directions. Okay, so whatever the angle is, okay, our magnetic field, that means the magnitude of the magnetic field that will be maintaining in a constant magnitude. Okay, so that is the thing. So how could I prove these things for the rotating magnetic field concept? Okay, so at the time of t, okay, the magnetic field will be the having a same magnitude. That means 1.5 bm. Whatever the values of t, either t will be 0 or t will be 90 degree, whatever. So whatever the value, when the omega t is equals to 0 or when the omega t equals to 90 degree, when the omega t equals to 120 degree, when the omega t equals to 240 degrees. So whatever the my angle is, my magnetic field will be the same magnitude, supposed to be 1.5 pm, and it will be continue to rotate at an angular velocity of a omega. Okay, so how could I prove this particular statement? Okay, so for proving this particular statement for the all the time t, okay, so now we have to prove these things. Okay, because we must have a justifications, na? We are during the trigonometrical calculation we are finding the what will be the magnitude. Okay, and what will be the values of the angle. Okay, but there must have a justifications. Okay, there must have a proof for the rotating magnetic field if it will be rotating in a counterclockwise directions, right? So for that cases we have considering the coordinate system. Okay, so those who have a lateral entry, okay, lateral entry, तुम लोग मैथमेटिक्स 3 किए थे इन lateral entry, lateral entry जो है. Yes, respond please,
Sir,
because
3 4 class में था.
the thing is that whatever the things later on what we are discussing, it will be purely based on the mathematics. Okay, because although we are considering the trigonometrical operation, okay, so those who have a lateral entry, you little bit concentrate on the mathematics. Okay, mathematics 3, because the coordinate system that will be purely based on the mathematics. So now we are proving this particular solution, we are proving this particular things using the coordinate system, right? So we are having a new value supposed to be we are having a two unit vectors. Okay, so coordinate system. Okay, so we are having a two unit vector, one is x and another one is y. This is for the x directions, this is for the x directions, and this is for the y direction. Okay, and we may consider the z mod, that will be for the z direction, but all of this we are considering using a three-dimensional axis. Okay, three-dimensional coordinate system. So if I will consider, this is my x axis, this is my y axis. Okay, and this particular axis we are considering the z axis. Okay, so my unit vector will be lies with this particular actions, this unit vector will be lies with this, okay, and this particular action will be lies with this. Okay, so in the coordinate system, the x direction is to be the right, so this will be the right side. Okay, and y direction is my the upward directions, so this side will be the right directions. Okay, and this y has to be the upward directions, and this one we can considering this downward, right? So the x direction is to be right and the y direction is an upward. That means the vector x bar vectors, this particular vector, okay, is the unit vector in a horizontal directions, this particular plane under the horizontal plane. So this particular vectors under the horizontal portion. Okay, so and the vector y, and this particular vector is the unit vector in the vertical direction. Okay, so to finding out the total magnetic flux density, so for finding out the total magnetic flux density. Okay, flux density in the stator, so we have to only simply add vectorically the three components. Okay, this components and this components. Okay, although we are not considering, because we are only considering the vector x and the vector y, as it will be the three-dimensional plane. Okay, so we will not considering, so we are considering only the cos functions and the sine function for that. Okay, so for that case is to finding out the total magnetic flux density of a stator of a stator. Okay, so simply we have to did what? Simply we have to add vectorically all the three component of the magnetic fields, and we have to determine their sum. Okay, so for that case is what will be the net magnetic field at a particular time interval t. Okay, so the net magnetic flux density in the stator, so we can say that the net magnetic flux density in the stator is given by we can considering b net at a certain interval of time t. Okay, so we will add. Okay, so we will add each and every magnetic flux for each and every coil. Okay, so what will be my ba dash t? What will be my ba dash t? BM at an angle 0 degree. So we can write over here, when we are considering omega t we are considering as a omega t. Okay, so omega is my angular velocity. We can consider it. Okay, so what will be my BA dash t? Tell me. That will be BM sine of omega t at an angle 0 degree. Okay, plus what will be my BB dash t? Can anyone told? Can anyone told? BM
Sir, sin omega t minus 90 degree.
sine omega t minus not 90 degree, it's 120. Okay, at an angle 120 degree, because what the values of b dash I am finding in the previous case, that will be minus 0.5 bm at an angle 120 degree. The same thing we are implementing over here also for the coil b dash t. Okay, we are adding all those things, right? So for that cases, for the third one, in this case, what will be my values? That will be bm sine of omega t minus 240 degree
240 degree.
at an angle 240 degree, right? So these are the all actually the components. Okay, these are the three different components: number one, number two, and the number three. Okay, so each of these three component of the magnetic field can now be broken down. So ये जो तीन components मेरा है, ठीक है, that should be broken down into its x and y component only. Okay, so ये जो तीनों component है, इसको अब हम redefine करेंगे using the coordinate system, okay, into its x component and as well as the y component only. So all those three component we have to broken down into its x and y component using the method of a coordination system or the coordinate system. So before doing that, we are overlapping the steps, okay, because of the it will take too much time, okay, if I will simplify all those lines. Okay, so before doing that, in your home you have to study the coordinate system is what the coordinate system, it will be there in the mathematics 3. Okay, so you need to be understand what the coordinate system is. For the x-axis, what will be the vector representation of a x mod for the coordinate system is. So you have to remember, understand this thing. So now what I will do, so there must have a three components, so we have to broken down all those three component of the magnetic field, okay, into its x and y component only, not the z component. Okay, so for that cases, if I will write again, so if I will write again, so my b net is, so what will be my b net at the particular time interval t? So that is, again I am writing bm sine of omega t at an angle 0 degree plus, again connection lost, again connection is lost. बार बार कनेक्शन लॉस्ट चले, क्लास ना आ जाए.
সেটা তো তার পাওয়ার সিস্টেম ঠিক করবে পাওয়ার সিস্টেম বলেছি আমি পাওয়ার সিস্টেম ভুল বলেছি পাওয়ার সিস্টেম আর পাওয়ারটা ঠিক বলতে পাওয়ার সিস্টেম আর সিস্টেম তো পাওয়ার সিস্টেম এটা তো আমি দশ সাল আগে লাইন শুরু একটা বড় সরকারের লাইন আমাদের কম্পিউটার ছবি সব বছর পরে দিয়েছে তুই কখন সরকার সরকার পুরোটি চাকরি না পুরোটি যাবে সরকারের ইনস্টলেশন আমাদের পরে ব্যাটারি খারাপ করে দেবে বেড়ে দেখুন করছে এটা টেরিটারি আছে যেমন এগুলো দেখতে
So each of the component we will break down, okay, into two single components. One is a x and the one is a y component. So what will be my b net? So that will be my b net t. That will be considered as bm sine of omega t for this one, omega t x mod plus of, sorry, not plus, it should be considered as minus, it should be zero point 0.5 bm sine omega t minus 120 degree x mod plus root 3 by 2 bm sine omega t minus 120 degree y mod. Okay, minus for the second axis, for the y axis bm sine of omega t minus 240 degree x mod, sorry, minus this one is also plus minus root 3 by 2 bm sine of omega t minus 240 degree y mod. Sorry, this one. Okay, so this will be, so combining, we have combining x and the y component yield. So we have to combine x and y mod component, right? So it will come b net t, that is equals to the big thing bm sine omega t minus 0.5 bm sine of omega t minus 120 degree minus 0.5 bm sine omega t minus 240 degree x mod plus root 3 by 2 bm sine omega t minus 120 degree minus root 3 by 2 bm sine of omega t minus 240 degree y mod. Okay, so using this, by the angle addition trigonometrical identities, we have to redefine again. Okay, so again we have by the angle addition, by the angle addition trigonometric identities, trigonometric identities. Okay, so what will be by b net t, that is equals to, bm sine of omega t plus 1 by 4 bm sine of omega t plus root 3 by 2, sorry, root 3 by 4 bm cos of omega t plus 1 by 4 bm sine of omega t minus root 3 by 4 bm cos of omega t tan angle x plus minus root 3 by 4 bm sine of omega t minus 3 by 4 bm cos of omega t plus root 3 by 4 bm sine of omega t minus 3 by 4 bm cos of omega t angle y dash. Okay, so if I will simplify this equation, so it will come v net t, that is equals to, that is equals to 1.5 bm sine of omega t for the x axis, x component, and 1.5 bm cos of omega t for y axis. Okay, so that is my actually the final expression of a net magnetic flux density. Okay, so net magnetic flux density. Okay, so I think I have to stop the session for today because due to the poor internet connectivity. Okay, so we will again continue the same session in the next classes. Okay, so thank you. All are requested to leave the session for today.